This, this kind of applies to, let me give you a heading for this page, 44. Why the concept of tolerance is important. Okay, let me, this is the one that I yet have to see students do a little bit better on an exam or on a test, is like when the question says, explain why in this case tolerance is important. The concept of tolerance is important. Really, you pick one, right? Use keywords, talk about what happens when it's too large or when it's too small, okay? Basically, that's what you want to use. Like, pick which case you want to address and tell your audience what's going to happen if you surpass the max, okay? So, let's see here. Medication. If it's too low, it would make it ineffective. Okay? If it's too high, could cause an overdose. Look, I even do fill in the blank. You're welcome, guys. You're welcome. Entrance door. If it's too narrow or too small, they will give you a specific scenario, so you just have to go with it, okay? If it's too small, would cause drafts. If it's too big, if it's too wide, it would be impossible to close the door. T-shirt, if it's too loose, like if you say this is an extra large shirt, but you make it way too big, then people are going to be like, well, this is uncomfortable. It doesn't fit properly. And if it's too tight, it will just simply not fit, right? So that's something like that. Battery, if the voltage is too low, okay, the device will not work or power on. That, honestly, that would be good enough. If you just talked about if it's too low, tell us what would happen. You understand the concept of tolerance. If it is too high, it would damage device. Let's do one with the fridge, but without writing it down, because I think you get it at this point. What happens to your food if the temperature is too high? Spoils, yeah. It'll spoil, it's not good. If it's too low, starts freezing, right? Your veggies start freezing. So in a fridge, you wouldn't want it too low, you wouldn't want it too high. Anybody know what the recommended temperature is in a fridge? 4 degrees Celsius, so just above freezing. So not 0, 4 degrees is kind of like what they're aiming for. Is the temperature inside the fridge always 4? No. Sometimes it freezes, right? Then you have issues with your freezer, or for your fridge, you might have to call someone. Sometimes if people, my kids always think it's a TV, right? It's like, right? The temperature will now go up because you're letting all the cold air out, okay? Speed limit on a highway, if you're too fast, you can get a ticket, you can actually get into an accident, blah, blah, blah. Do you know that you can go too slow? Like certain highways, if you go too slow, you can also get pulled over, okay? So, something like that. Just use your judgment on that one, okay? So tell yourself on your study sheet, if I'm asked to explain why tolerance is important, address what happens when it's too high, address what happens when it's too low. That's it. That's it. I want you to copy this question way back, 66. I could have used 67, but I don't think I have a 67. Oh, there is a 67. I'll use 66 for now. Go to 66 and write this one down. This is like, this could come your way, okay? Sometimes the province wants to know, are you just memorizing things, or do you understand what happens? 66, all the way to the back. I call this extra, so I'll add stuff to this. Let's see how you did. If the minimum is 1, then that means that there's a max somewhere, right? This is my min. This is my max, which is unknown at the moment. I know that, oh, what did I say here? Okay, the nominal, which is halfway, this is my nominal here in this case, is 5 centimeters. Okay. So what can we do here? It's a four difference, right? So this is
attention, Marie Anderson, to the, your bus is waiting, Marie Anderson, to the school bus, please.
so if this is 4, then this will also be 4. Okay? So the max is going to be what? If I go from 5 and I add 4 to it, the max is 9 centimeters. Okay? What would the tolerance have been? Go ahead. What's the tolerance? 8, right? You can go 4 and 4, or you can go 9 minus 1, right? The tolerance would be 8 centimeters. So they could have asked, right? Because you know this is 4 to get to there, it's going to be another 4 to get to the top, because you were told that the nominal is halfway in between. That's the key here. If you didn't know that, then you couldn't solve this. Okay? Let me show you some exam questions here. You ready? They're not that hard, in my opinion. So this is January 2018, before COVID. Okay. Choose the letter that best completes the sentence. How close a measurement is to the true value refers to? What would you say? How close the measurement is to the actual value? Accuracy, right? That's accuracy. Okay, let's see here. Could you do this one? Jordana's having a ring made by a jeweler. Her ring is to weigh this much. Calculate the uncertainty of the weight of her ring. Do not round your final answer. Before you do uncertainty, what do you need before that? Yeah? Any uncertainty would be half of that, right? Boom, you got the answer. You're good to go. 1 mark. Move on. Okay? Next. Joan Ali is a veterinarian. Her thermostat indicated that a dog's temperature is supposed to be 38.6. State the precision of the thermometer she used. Some are easy. Some are just, it says state, right? Did you notice that it said state here? What did it say here? Calculate. So that kind of implies a little bit of work when it says calculate. Okay. What about this one? Mario's installing subfloor using sheets of plywood. He measures the plywood to be 225 centimeters long using the tape measure. Construction workers don't use centimeters, use feet and inches, but anyways. Calculate the minimum possible length of the sheet of plywood. What will be step number 1 here? To get the minimum, what do I need? I need to write this like this. Plus or minus the uncertainty, right? So precision is 1. Uncertainty, therefore, is 0.5 of a centimeter. So what's the minimum? 225 minus 0.5. Okay? 225 minus 0.5. So it'll be 221.5. Oh, no, sorry. 224. My bad, right? 225 minus 0.5, 224. Okay. What about this one? This is more related to what we did today. I'm actually curious if you want to try this on 66, you can do that. Choose the letter that best completes the sentence below. The tolerance that allows for a maximum value of greater than 16.5 centimeter is maximum value of greater than 16.5. Which one of these? This one allows for, what's the max on this one? 17, right? That's the one, actually. We found it already. But what's the max when you have this format? 16.5, right? That's why you want to have this on your study sheet so you kind of know the formats. What's the maximum here? 16.5, yeah. The maximum here, 16.5. They tell us to put units everywhere, but they don't do it themselves, right? What's going on there? So the one that, in this case, would, you just care about the max, right? Which one has a maximum of greater than 16.5? That's the one. So do that inventory if you have to. Do the inventory, find all 4 for each one of them, and then you got it, okay? What about this one? Read it and try it, and you can use this page 66 to do some work there. Try it. It wants you to state the tolerance in that format based on the info you're given. You want to write this down on 66. Just go minimum is this, maximum is this, write it like this. It's as easy as that. You don't have to copy the whole thing. It's the decimals that threw students off this year. If the max is this top line here, that's 2.022. The min is down here, and that would be 1.896 millimeters, right? Can I find a tolerance based on this? For sure, right? I actually need my calculator for this because it's Monday and I don't want to. .153, right? Is this a tolerance? So I'm almost there. Does that make sense? Yeah. Do I know the maximum already? I do, right? So I can write it like this, 2.022 millimeters plus 0 millimeters minus tolerance. You've got everything you needed right there. So that would give you the 1 mark. Yeah. Oh, yes. Thank you. So what's the tolerance? 0.126. I'm just going to go with it, okay? So this goes here. What do you think would have happened on the exam if you had made that mistake? You would have lost half a mark. Yeah, unfortunately, all that work, we know you know what you're doing. However, I can sometimes be creative because there are certain errors that are called communication errors. When we see that you flipped it, you only lose one of those for the entire exam. So if I bubble in that bubble saying that you flipped a number, you didn't copy it right, if this were to happen to you again down the road, you wouldn't lose a mark again for that. So that's kind of, I always try to do that so that you get the most of it. Okay? Let's keep going here. What about this one? On 66, try this. This is the last one, right? Hold on. Is there another one? Yeah, this is the last precision on this exam. There was one more question that I skipped because it was not, right now I didn't want to deal with that. What if you got something like this? Iron needs to be heated between 230 and 280. State that measurement in that form. How could you do that? We complained, just so you know, we as teachers complained when they did this. What are we assuming the nominal is when only the minimum and the maximum is given to you? We're assuming that it's right in the middle, right? We're going to add them, divided by 2. So nowadays, you're usually going to see a statement, assume that the nominal is halfway between the max and the min. Like now, like after COVID, they have that sentence somewhere in that problem. And that, I mean, that's a huge giveaway. Oh, I need to add divided by 2. So give this a few seconds. What's my nominal, guys? It's 255. Okay. Okay, you would get 2 marks for this page, right? So nominal is 255, and we are in degrees Fahrenheit. Plus or minus half of what is your tolerance? We know it's 50. And we're in degrees Fahrenheit. So just put degrees Fahrenheit everywhere and you're safe. You would get 1 mark for the 255. You would get 1 mark for the 50. That's it for today, guys.